Welcome back, everyone. This is iOS Stage, and we have another speaker. I hope everyone is enjoying their time in the 3D world and at the talks. Our next speaker is a longtime iOS developer and person passionate about graphics and UX and animations. He creates mobile apps for living, for example, at Trinidis or Kiwi.com. And he's sometimes speaking in conferences and programming, teaches programming, of course. With his talk, Generative Art in SwiftUI, I would like you to welcome Pavel Žák. Hi, Pavel.
Hi, hello everyone. Shall I start already? Probably yes. Okay, so hello everyone. My name is Pavel and I'm addicted. I'm addicted to creating of animations in SwiftUI. And in this talk, I would like you to take you to visit my animation kitchen, and I would like to share some of my animation proven recipes or workflows that I use really often to get to the results that I like to call generative art, but it's not up to me to mark it as an art. So that's why it's in backslash. So in the beginning, I need to complain a little bit. Let me ask you, when was the last time when you get your hands on a new app and you thought, holy moly, this is a beautiful app? Or this transition, how did they do that even? Honestly, I no longer have these experiences. Definitely not so often since Jancho Ilavsky is out of business. But we need to be positive because SwiftUI is all around for some time and it is awesome and it lets you create awesome looking outputs, transitions, animations without extra effort. And that, my friends, that is a fact. So when I first get my hands on SwiftUI in 2019, I believe, the animations was the thing that actually got me hooked to how this new experience. I have immediately started to write games and play with different transitions, filters, and writing new components and controls that I didn't even imagine I'm capable of writing before. And I found once again a joy in programming and once again joy in doing UI. Sadly, nowadays, still my main project is in UIKit, supporting iOS 12, so there is no use of SwiftUI so far. So I try to find the new opportunities to actually do some SwiftUI coding. And since I don't drink coffee, I found the great opportunity to create animations is during coffee breaks or lunch breaks. And it happened a custom of mine. Then when I'm bored or I need some reset of my mind, I simply set to a fresh SwiftUI project and I do some animations. So in the last year, I have created many weird and even dummy animations just for the joy of the process of creating them. And I have put together a little demo reel, let's call it, a little sample of what I was able to achieve and to actually showcase you what SwiftUI is capable of doing it. So please, director, play. Thank you. Back to the presentation. So in the end, I figured out that I somehow follow the same patterns and use the same techniques. So let's have a look on some of my trusted toolbox that I use every time. But I need to start, sadly, with a little boring topic. And this is, I would love to tell something about how actually SwiftUI interpolates things and how the animations work under the hood. Everything that is animatable in SwiftUI implements protocol animatable, as you can see. And there is associated type animatable data that implements vector arithmetic and additive arithmetic. Why those two arithmetics? Well, the animatable data is the way for SwiftUI to actually do the interpolations of parameters for your views, for your shapes, or for your modifiers. And when the interpolation happens, what SwiftUI does is that it has the state at the beginning of the animation. You may represent it as a vector with 0, and you have the final state where you want the animation to end. And SwiftUI simply computes the difference of these two vectors. And during the animation, it interpolates these intermediate vectors by the following equation. And you can see that the equation depends exactly on the stuff defined by the vector and additive arithmetics. So it's what we have been learning in high school, but we didn't know that it's actually useful for something. So to be concrete, we can have a circle. We want it to animate to a new position. We have a vector, and SwiftUI will do the interpolation. That means it will provide us with all the intermediate values during the interpolation. So it happens like this. And it happens according to animation curve, but in the linear way. So that means that it cannot move around some curve by itself, but we can change it. If you want this scenario, like having circle, again, move it somewhere, but you need to animate it through some intermediate step. You either had to split it into two animations, or you can utilize the services of geometry effect. Geometry effect is, in fact, another view modifier, but its main purpose is to change how the view is being projected onto the screen using this function effect value. During the animation, this function is being called repetitively, and you can alter anything about the view projections. That means you can change the rotations, you can change the translations, you can change even the projection itself. And with this, you can implement behavior that is not ready out of the box. That means that you can animate things along curves, you can do there and back animations, and for example, if you need some simulation of physics or something, or pseudo physics in your animations, geometry effect is the right tool for that. The best example is particle effects. So if you implement particle effects, the movement of the particles and also here the movement of the emitter itself is being controlled by geometry effect. Another example is this particle effect. Again, every dot, every particle is single view, whose displacement is being controlled by geometry effect. I seldom use rasterized graphics or images in my animations. I rather use shapes, because shapes are vectorized, and so you can scale it as you wish, and also parameterized. That means that you can create shapes that actually can change during the animation when it depends on some parameters. So here is an example of this circle with lines. It's nothing complicated. You only need to implement main function path that actually returns the path which is the description of your shape. And it's pretty similar to other drawing APIs that you might be familiar with. So you have some virtual pointer, and you just control it, move it around your canvas, and you can add some primitives like lines, arcs, circles, rectangles, etc., etc. Even with shapes, you can have a lot of fun. This is what we saw already. So here I have implemented a magnetic curve, and only by changing its parameters, you can get quite sexy, I would say, and appealing result. The same story goes here. Again, this is from my snowflake generator, and every snowflake is a custom shape with its properties being set differently and randomly. Now, let's have a look at one of the cool features that people may not aware of, and that is the simple thing that when you are implementing a view modifier or Animatable modifier, you can mess with the content in the way that you can multiply it or even discard it and replace with another content. So here I have a mirror effect that splits the view into two halves and then masks each half with the mask and then combine it back together. So you can create this mirror effect, taking one half and moving it across the view itself. This allowed me to create this effect of kaleidoscope, where on the left you have the source view, and on the right there is the source view with this mirror effect applied. So you can have a nice effect that people may wonder how it's been done. Another way of getting interesting outputs is setting different delays for different actors on the animation. So let's start with the three circles that move in not very interesting way. Now, if we change each circle with the set of multiple circles and change the delay parameter for each circle, either randomly or by some simple step, the animation may be much more interesting, and you can get really crazy when you do rapid changes of your parameters like here. Blending is one of the simplest view modifiers that you can use. And if you are familiar with Photoshop-like softwares, it's no new thing for you. So by setting blend mode, you can mix the layers of your views together. So you can change opacities, colors, multiply colors together, etc. I especially like this blend mode plus lighter when I have views on a dark background, which has been set up on this example. Here we can see hundreds of lines. Each line is a random walk in the random field. And each line has this parameter blend mode set up. So you can see that the colors blend nicely together. And it's very useful for this type of glowing effects. And that's exactly the power of the view modifiers of SwiftUI itself. So you may have effect like the glowing effect or changing, shifting something, multiplying something, and you can wrap it into one modifier, and you can use it across your project, across another project, or even use it repeatedly on the single view to get interesting result. Again, here we have three dots that move according this modifier, shift, and multiply. It looks pretty dull and boring. But if we add another layer of the modifier, we get more mass. And by another use of the same modifier, you can see that we are getting some interesting results and some patterns in the chaos that we had earlier. So this one, I came to this really by just random playing with the view modifiers, no thinking ahead. People often ask me how I come up with my animations. So when I was preparing for this talk, actually it was on Monday, I tried to come up with some case study. And just that day, I read about the spinning optical experiments that were done by Marcel Duchamp in 1935, where he used these spinning circles to get some interesting optical illusions. And I like this geometric appearance of the circle. So I tried to recreate it. I started with the view that was just a bunch of circles with different offsets, and I tried to animate it, and it seems okay. So as another step, you already saw the shape of the circle with the line. So I exchanged some of the circles with these filled circles to get the feeling more close to what the Duchamp already had. And then I just played with it, change colors, thickness of the lines, blending modes, as I showed you before. And I found out that I really like this way, but that I'm drifting away from the original idea that it should resemble the original rotodisk. So I have decided just to blur it and mix with the shape itself. And this is the result of the animation that I spent just a couple of minutes, basically, and I was quite happy. And this also covers my workflow, and as you could see, all the techniques that I was describing before. So now we could discuss, is it even good option to start doing animations with SwiftUI? What about the performance? Or you may have another question. So I would like to invite you to Speaker's Corner, and so we can cover these topics. So is there any takeaway? Should you start doing these silly animations like me? Well, I would love you just to make awesome apps and take breath away from the users of your apps. Thank you.
Thank you very much, Pavel, for your talk. It was awesome, as always, and it was delightful to look at. I encourage everyone to go and find Pavel in the 3D world for the further Q&A and to get to know him more and to debate all of you could have learned right now. Please engage on the social media, tweet or post with the hashtag mdevcamp or mdevmeetup. And I would like also to remind you that there are some competitions and quests going on. I hope you have already discovered the flying feature, which you have to work for it for a bit. And we will see another speaker in another 40 minutes, I believe. And then after that talk, there will be some lightning talks. And also, don't worry if you didn't catch, for example, the beginning on the first talk. There will be recordings of all of the talks. And something else I should remind you, I believe not. Just have fun, find your speakers, take the advantage that you can meet them in person, even though we are not in the same room. So social distancing for the win. Thank you very much, Pavel, once again. And hope I'll see you all at the next talk and also in the 3D world.